Welcome to 10 Minute CS. 2707 extra characters in a string. We are given a string S and a dictionary, which is list of strings. We need to split the string S into non-overlapping substrings such that all those substrings are there in dictionary. For example, we are given string S, leet S code. Let's say we plan to break it into leet and then S and then code. So the word leet and code are there in dictionary. So the remaining extra character is S, which is just one. So we return it as 1. Similarly, for say hello world, hello and world are present, but say is not present, which is of length 3, and so we return 3. We need to break the characters in such a we need to break the string in such a way that the number of extra characters left over is minimum. Let's say we plan to traverse through the string S from 0th index till the last, and each time we will check whether the character we are at is that if there is a string in dictionary, so we will take that word and we will move on to the next character. So such for example, we are at 0th index and we have the character L, and we see the string starts with lead is present in a string. So we will move on to the next character, which is S, because 0 and the length of it is 4. 0 plus 4 will be 4. We'll move into the S, and similarly we can check for it. Now S is not present in dictionary, so our output will be increased from 0 to 1, and we'll move to C. Now code is present, so we will move on to the next index, and we have reached to the end of it, so we'll just return our output variable. So each time we are at any character, we need to check in our dictionary whether there is a word starting with that character or not. This traversal over the dictionary, we will take another O of M operation for if it has M number of strings and each string is N. So time complexity will be high in this case for just searching. How can we reduce it? We can maybe take a map of key as character and values as list of strings. For example, we have the character L, we can have leet and Leetcode here as its values. This will reduce the complexity of searching throughout the dictionary to O of 1. Now there is another thing. Let's say we are given that same example such as leet as code, and we have our dictionary as leet and its code, and we can have multiple options of breaking into substrings. Let's say first we break it as leet s code, and there is another which is leet and s code. For this for this one, we check that there is a string that starts with L, and we plan to take it, so we will move on to the next one. Now there is no string which is starting with S code, so we will be returning 5 in this case. But for the other scenario is, though we have a string which is starting with S, but we plan to discard it and move to the next character, and now we see that there is a string which starts with E. In this case we return 1. So this is the optimal way of breaking it. So as we discussed here, for each character we have two options. Either we discard it and move to the next index. Let's say we have a helper function, we will move to our next index and compute the values. In this case our output will be increased by 1, so 1 plus helper function. Or the other case will be, we move to the next one, so our output variable is not increased, but our index will be increased with the length of the string. And finally, when we we can find the minimum of both of these approaches and return it. So the approach is simple. For each character, we will check whether that's present in the dictionary, and we have two options for it. First one is we will just use this formula and move to our next index. Other one is we will check if it is present in the dictionary. Yes, and in that case we will check for all the strings which are present there, and with those strings we will check if our um, string starts with it. Let's say we were at L and we have a string lead here. We will check if this string starts with the string lead itself. Then we can use this formula and compute our values. So the time complexity for this approach will be big O of 2 raised to the power n, because for each character we have two options and a tree can grow up to n, which is the length of a string. And the space complexity will also be 2 raised to the power n, considering we are using recursive stack space. Let's go to our code. We have created a map of characters and array of string. For each of the string in our dictionary, we are taking the 0th character of it. Now we are checking if map already has a key similar to it. If not, then we need to create that key with a new array list, and finally we are just adding that string to create our map here. Now we are moving to our helper function, which has string s and index 0, and we have the map. Now for each of that, let's say we are at index I, we take the character C. The first way is we are not considering that, we are not checking in the map whether there is a string or not. We are just discarding it and moving it to the next index. In that case we will be having one leftover character, so we increase it to 1 plus. Other one is we initialize our with C, that is considering that character strings. We are initializing it with the remaining characters left in the string, and we will check if the map contains the key. If so, for all those values in our map, we check if the string starts with that string. If yes, then we will move on to the helper function, increasing our index value with the string length, which is this one. And finally we are just checking the minimum of all of those possibilities, and finally returning mat.min of with C and without C. The edge case will be when we have reached to the end of the string. In that case we should return 0, as there are no more characters left, so the residual characters will also be 0. If we try to run it, we see that we will get a TLE. We can use memoization to optimize it. We can use a 1D array, as the only changing variable is the index, and we initialize it with string.length +1, and we fill it with -1. Then we will check if there is already an existing value for that index, then we will return it, and we will keep on adding populating the values for that index. This will prevent the recomputation of the already computed values. So let's say for this case we already have, let's say we are moving on to our subtree, and we already have computed the values for it, computed the value in this scenario, so we don't need to recompute it here. This will prevent the recomputation. So now our time complexity will be O of n, which is the string length, multiplied with m, where m is the values length of our dictionary, which can also be taking the length of our dictionary. And our space complexity will be big O of n, which is the DP array. Thank you for watching.